Lincolnshire Aviation Heritage Centre. On December the 1st, 2023, Andrew gave one of his talks on the restoration of Lancaster NX611 to airworthy condition. Part 1 went out on December the 6th, so this is part 2 of 2.
The rear fuselage.
Thanks for watching.
So, if you'd like to follow me down to the restoration area, if anybody's bored, feel free to leave. This is a good opportunity because I won't notice. So we'll go down. Okay, so down here is our main restoration area. This is where the parts of aircraft come to be broken down, restored to either airworthy or taxiing condition, and then taken back up to the aircraft. So kind of from the barriers this way is the effectively the licensed area with the CAA. This is the main restoration area. So up there we've seen the rear fuselage fitted to the Lancaster. This is NX611's rear fuselage. So this is the fuselage jig and NX611's rear fuselage broken down into component parts, being rebuilt back up to an airworthy condition. So you can see here basically how skeletal the monocoque structure is. So here the vertical sections are what we call formers, or what Avro called formers. They're called frames in other ways as well. And then between those vertical frames you have the horizontal stringer. And the stringer is an extruded section, so it's a right angle with a little bit of a bulb on it for strength. And that runs from the forward transport joint back to the where the rear turret fits onto the rear fuselage section. So up on the shelf there is the rear turret section. So that's where the last former is, and the turret sits in that basin effectively of that section there. That attaches onto the back of the structure in the jig here. So this rear fuselage section has been completely taken apart. So all the formers have been removed, repaired or replaced where required. All the stringers have been removed and repaired or replaced where required. And it's now at the stage where it's being pinned back together, trimmed where needed, everything test fitted, removed and painted if it hasn't already been painted. All the rest of the holes drilled in, ready for the structure to start to be riveted back together. And once the structure's all good inside, the skins can be laid on as well. So we've found quite a few problems with the rear fuselage of NX611. So the aircraft has been taxiing here at East Kirkby since 1995. And when we count up how many numbers of pairs of feet have been through the aircraft, you start to understand why we're coming across the damage that we are. So within the rear fuselage section there is just a small walkway which is about 12 to 18 inches wide, and that walkway sits on top of the formers and on intercostals. Thank you. So we found quite a lot of damage to the bottom of the formers. So the formers in the fuselage are in halves. They attach top and bottom bolt together to create the entire cross section. And the walkway sits on top of some of the formers here, leaving some of the bottom of the formers completely bare. So as people have walked up and down the fuselage, moved to the side to allow somebody past, something's been dropped, a piece of equipment has been fitted with a bad hole, it's damaged the bottom of the former. So as long as you all promise not to poke each other in the eye and smack each other on the head with this, because it's quite unwieldy, you can pass it round and have a look at the bottom of the former here. So this is a good example of, is that former worth repairing, or is it too badly damaged and needs replacing? This one needs replacing. When you start looking and you find damage here, you find damage there, you find damage there, by the time you've repaired it, you've got so many joints within that structure, it's no longer strong enough to be airworthy. So this has had to be completely replaced.
Who makes that decision?
So those decisions are made by our chief engineer and our deputy chief engineer. So the company is structured as such that there is the accountable manager, myself, and then we have the chief engineer who makes the engineering decision. There's a deputy chief engineer who works with him and just beside him, underneath him, who's effectively in this position. He's on the shop floor all the time. He's overseeing all the restoration work. And then we have the engineers actually doing the restoration work to the parts of the aircraft. So these parts, as they're removed, are first inspected by the engineers on the shop floor to say, does this need further inspection, or is this piece undamaged completely and should be airworthy? If it needs further inspection, then that is inspected by the Deputy Chief Engineer or the Chief Engineer, and he makes the decision of should we repair this part or do we need to replace it. If it needs replacing, then it obviously goes into one pile to be replaced, repaired goes into another pile. So with that decision made, so the formers, for example, they're all produced here. Thank you. So this is an example of a former that's kind of 3/4 of its way through production. So this starts out as a flat piece of aluminium. We use a wooden template. Dave, have you got any wooden templates there? Have you got any wooden? Yep, so we have wooden templates. My glamorous assistant. This is clamped between two templates and then it's formed. So the sides are knocked over, shrunk or stretched where required using the stretcher and shrinker, knocked over again until it creates the actual shapes that you need. The biggest danger with creating these is actually starting to split the material. So the edge of the material has to be completely smooth with no burrs, no defects, no splits, because as you start to stress that material by bending it over the wooden forms, it will just crack. And if you overwork it, it becomes work hardened, which will of course create it to crack and split as well. So Dave's created or perfected a technique of doing that work here using the wooden forms and the shrinker stretcher to create items like this. So if you promise not to drop this, I'll pass this round as well. So this new former is at a position now where it's ready to be cleaned, go off to paint, and then it will come back ready to be trial fitted to the fuselage. To show you some of the stringers as well, could I have the short stringer? So I say the stringers run from fore to aft, interlocking the formers and creating a lot of strength. So this is an example of a stringer on the aircraft. What we found with the rear fuselage here is when it was in French service, it has been reworked quite a lot at a time. And what we found is when they've drilled out the original old rivets, they've drilled out with shall we say, a bigger drill bit than they should have done, which has meant that when we've removed this, when you remove a rivet, if the hole is slightly damaged, which is generally the case, you have to go up a size of rivet. Now these are beyond being able to go up another size effectively, so they have to be replaced. So I'll send this round and you'll see, when you see the whole of a rivet, there's supposed to be sufficient material all around it to be able to oversize to put another rivet in. If we oversize this hole to the next size of rivet, it removes that minimum requirement of space around the rivet called the land. So it's the amount of space you need of the raw material to retain the strength of the item. So I'll send that string around as well. So because of that, we have to replace the stringers. Another thing you find as well is when you put a rivet in a hole, so when you form a rivet through a hole, so you have a skin on the outside of the stringer, you put the rivet in through the skin, through the stringer, the rivet gun on the outside and a block on the inside. And doing that, reactions with the rivet gun through the head of the rivet, out through the tail against the block, and reactions to the rivet squashes the tail of the rivet to pin all the items together. By doing that, also affects the hole and stretches the hole within the stringer. And when you do that, it stretches the material. So if you look at that, that was once straight until all of the rivets were fired in, stretching the material. When the material's within the structure, it's got nowhere to go. But when you drill out the rivets, the material relaxes, stretches like a banana, which is what's happened there. So that was straight on the aircraft, been removed from the aircraft, and because of all that material that you've stretched by putting the rivet in, it's relaxed into a banana shape. So within the rear fuselage structure here, you've got the formers, which are the cross-sectional shape, you've got the stringers running fore and aft, and then in the floor you've got something called an intercostal. So if you could possibly just pass me that next piece on the bench. Thank you. So an intercostal runs between the formers, between the frames, on the floor, and carries the floor, carries the weight of everybody walking on it. So this is an intercostal. So this attaches to a stringer, and then attaches fore and aft to a former and basically sits in between the formers. So this is an example of a damaged intercostal in the floor, again through wear and tear. It's got a crack in it, it's got oversized holes, and it's got a dent within it as well. So this is another intercostal which has had to be replaced to carry the floor, so I'll pass that round. There's a few other issues we found in the rear fuselage, in the fact that because the formers overlap and rivet together, top and bottom, we found corrosion between those two faces. Normal aviation principle now is you put a jointing compound between two adjoining pieces of material. So we use a jointing compound called Duralac, and that's tried to stop moisture getting in that joint and festering away and causing corrosion. During the production of these, there's very little jointing compound used. You were lucky if there was a layer of paint between the two faces. So obviously after 80 odd years, taking them apart, with that moisture and air getting into that joint, it started to corrode the materials. And on aluminium, you find corrosion manifests itself in basically a white powder between the two faces. So when you start seeing that white powder, which is aluminium oxide, very similar to rust on steel. So rust, obviously it's brown, you can see rust quite easily. The aluminium oxide is white and powdery. When you see that, you know that there's been corrosion within there. Generally, they say that the limit of the material you can lose is about 10%. So if the thickness of that material is diminished by greater than 10%, then it's no longer usable, it's no longer able to be made airworthy. So that's some of the problems we found where the joins are with the formers. Thank you. Everybody survived? Everyone got all their eyes? Thank you. So the rear fuselage now is starting to get to the stage where it's coming back together. We'll start to see very shortly where we start refitting the stringers and formers, riveting them together with the cleat. The cleat is basically an angle bracket that holds the former to the stringer. I think on the small piece, wherever that's gone, there's a similar thing to a cleat on the end of that. So those will go back together. We still have the transport joint to remove, which is the very forward extruded hoop, and we have the two extruded sections here which are either side of the tailplate. So those have yet to be removed to be de-riveted and inspected. A lot of wartime aircraft, when they were produced using a magnesium alloy rivet, and that magnesium content of that rivet has meant that 80 years on it's pretty much powdering away because of the reaction with the moisture and the oxygen in the air. So all of the rivets on the aircraft have to be replaced, and we're replacing with a hidaminium rivet, which in colour is purple. So if you see purple rivets, they're hidaminium. And so just for the longevity of the Lancaster as a whole, even if we weren't making it airworthy, we would still have all of these rivets to replace, because we want them to come apart on our timescale, not on their own, and start de-riveting the aircraft of their own accord. So that's where we are with the rear fuselage. It's coming back together again and should be finished in 2024. Over here you can see the port wing of NX611. So on the end of the wing there's a photograph of it as it arrived and been put into the jig. So this wing was in a very sorry state. So if you imagine the aircraft was sat out on Wallis Island for 40 odd years out in the elements in the Pacific. It was damaged through corrosion and through the taxiing accident, and also through the locals robbing parts off it, hitting it with axes and throwing stones at it. There's stories of the locals thinking that it was haunted because the aircraft would warm up in the sun and cool down, and as it does that, as you know with your house, it starts to creak and bang and clack about. So they thought that it was haunted by evil spirits, and so they would throw things at it or avoid it. There's quite a few things robbed off it as well. So the fuel tank panels were robbed off it, taken off it and used as roofs of huts, and anything they could rob off it to help themselves, they did do. So this wing here has come completely apart. And so anybody who came on a winter restoration tour last year would have seen it in pretty much component parts. So as you look into the wing here, I'll try and explain what I was trying to explain to you on the wing of NX611. So at the bottom here you have the rear spar. So you've got the spar boom and the web, and when you look inside the fuel tank bay here you'll be able to see the booms. The booms are basically L section in profile, changing from a small shallow L at the end to a square cube at that end. So the profile changes all the way up, and that's obviously to do with the stresses on the wing as the aircraft flies. What you'll find is that the top booms are compressed, the bottom booms are stretched as the aircraft flies. So if you go on a civil airliner today and go fly out, you'll see the wing will lift as you take off. It bears the weight of the aircraft with the lift on the wing, and you will also see them wagging and flapping about. So it's important on a wing that the structure can actually move and take those stresses and stretches and compactions within the materials. So you have the rear spar and the front spar, which is at this rivet joint here. And then in between those you have the ribs, which are these. So the ribs are aluminium sheet and then extruded sections on tops and bottoms. And those bolt between the front spar and the rear spar. So there's L brackets that bolt them to the spars. So that's the main box strength of it. There's then stringers, very much like the fuselage. There's top hat stringers which bolt through to those extruded parts of the ribs, and then the skins are riveted onto the stringers, making that monocoque structure. So the skins basically add a lot of strength to it and are stressed skins when the aircraft flies. And inside here we have the fuel tank bays. So this is the smallest fuel tank on the aircraft, number 3, and then that's number 2, which is the second largest tank. And then inboard of that is the number 1 tank, which sits between the inboard engine and the fuselage. So as we were looking up at the wing, looking in that gap beside the engine, that's basically here. So you can envisage where we are on the aircraft, where the fuel tank that had to come out is this one here. So this is the bottom of the wing and that's the top of the wing. So we're at the stage now where the majority of the skins have been riveted onto this. We have the fuel tank panels left to do. So this tank panel is pretty much almost finished, bar a little bit of trimming and the fitting to the tank bay. And then the number 3 fuel tank bay cover was non-existent. It completely left the aircraft. The French don't have it, no idea where it is. So we have to try and they've got 2 starboard ones, but not a port one. So we had to try and find another number 3 fuel tank bay panel. And we managed to find one out in Canada, and it was shipped back about a month ago. It came back into the country. So we now have this tank panel to repair to fit to the port wing here. The problem with the panel is it's actually shaped, so it's not just a flat square. It follows the shape of the wing to make the aerofoil of the wing. So the major sections we need to try and keep are these curved sections here. Everything else is straight, so we can quite easily repair and replace where required. So that's the next project for Keith, who's working on the wing, and this fuel tank cover as well. And then, when those are done, we need to fit the pickup point for the subframe, as I was saying, on the wing, and then the 2 front ones bolt on there as well, and then we can pretty much remove it out of the jig, have it painted, take it and fit it to NX611. The biggest problems we've found with this wing are both corrosion. So if you all hold your breath, I'll show you a powdery bit of aluminium oxide. So this is a stringer out of this wing, and you can see with the white powder on it, that's how aluminium oxide goes, that's the corrosion. So a lot of corrosion on it because it was left out in the elements for so long. So the corrosion here. And also a lot of damage to it, mainly by it being transported back to France, strapped down on barges and lorries, and over-tensioning the straps and bending structure. And of course, where the corrosion has weakened the structure, it's going to break more easily as well. So everything had to come apart. All the rivets were powdery and flaky, so they've all had to be replaced. Everything inspected, repaired to a taxiing condition, and put back together again. So it may look, well, it may look like a lot of work. It is a lot of work, but what we've really gained from this is a knowledge of how the wing works and how it was built. We thought that it was built up all in the jig. So the spars are put in, and then everything was built up around it, riveted together. What we've actually found by taking it apart is it's all built as small assemblies or sub-assemblies and then assembled within the jig. It's just an assembly jig really. So the leading edge, which is the top of the wing as we see it, so this is the spar, and then the skin overlaps the spar a little bit to here. So the leading edge from the spar upwards is built on a leading edge jig as an assembly. The rear spar is built on a jig as the spar booms and the spar web. The individual wing ribs are built in individual jigs as assemblies, and then all the stringers are obviously the shape they are through being extruded. So what they actually do on a jig like this is pick up a rib out of a box that says rib number 24, slot it in 24, 23, bolt it together, rivet the skins on, and it's out the door. So that is how the aircraft industry went because of wartime pressures. It's very much like the Ford Model T production line, how all that changed production. So it's not like a Spitfire, so to speak, that was a little bit more like everything is trimmed and handcrafted. No Spitfire is the same as any other Spitfire. This is very much mass production, individual sub-assemblies built on benches. So one person, every day, they're just making rib 24, making rib 24, it's just going out the door in the box for the next part of the assembly and production line. So all the sub-assemblies brought together, held in a jig, bolted and riveted together, and it's out the door to be fitted in the next part of the factory to be fitted onto the aircraft. So we've got to adjust this jig from what we thought we needed to what we now know we need. So we found that, thankfully, now found a photo of the original jig that does this job. And what we actually need is a structure over the top that holds the leading edge and stops, because amazingly, the spar booms and spar web and everything is really flexible. If you picked up the outboard edge of the spar and lifted it up, it would bend like a piece of paper. There's no real strength in that plane of the spar, that the strength is in that plane as we look at it rather than in that plane. So it actually begins to sag between these pillars you see here. You can tell the spar itself is actually sagging because the strength of it is in that dimension, that plane. So the leading edge is very much the same, so we have to have a structure over the top, effectively sets of goalposts that hold on to the leading edge of the spar and keep it all straight. So we would set the rear spar, set the front spar, and then all of the ribs are just brought in individually, bolted together, and then the skins go on. So when this comes out of the jig, our port wing will come down this section. Some parts will be dressed across from NX611's wing, which are required on this to taxi with, and then the jig will be changed, and our port wing will go into the jig. So I would imagine within this year, the wing will be finished and ready to be fitted to NX611. So we have another restoration tour like this on the 20th of January, I think it is. Hopefully by that point, NX611's wing will be off, and potentially this wing will be looking to be ready to be fitted. So that will be the first time that we've had the wing off the Lancaster since it was moved here in 1988. So it's quite a big moment for us here at the centre, and a big visual piece of progress for the restoration of the Lancaster as well. So NX611's wing, we fitted to the jig, and then we'll start taking it apart, see how much damage there is. We know there is some spar work to do, so there will be some replacement spars going into the wing. But the biggest problem with that is finding a company that can machine a piece of material as long as this spar is, and to take it from an extruded section down to a machined, correct shaped spar boom. When we had the spar booms off this, we actually had them 3D scanned, and then those 3D scans, that model can be checked against the original drawings to make sure it's correct, plumbed into a CAD-driven machine, and they can mill out the spar booms for us. Over the far side, you'll see another piece of fuselage section. So that's the fuselage section in kind of a light green colour. That's the next piece of fuselage of NX664 from France. So at the moment we have NX664's port wing tip, port trailing edge, mid fuselage section and nose section. So we've almost probably got more of the French Lancaster here than they have back there. So once the rear fuselage is finished, that mid fuselage will be ready for taxiing. Depending on how much work needs to be done to it, could be ready to fit next winter. So again, to allow us to take our mid fuselage off, fit it to the jig, because this jig can be adapted to do both pieces of fuselage. And again, the process starts again, restore hours, swap it back out, and the bit goes back to France. So we set out a 10-year plan back in 2015-16 when we did the paint strip of the aircraft, and we're currently starting year 6 of that 10-year plan. We lost a year because of COVID. As you can imagine, we didn't get much work achieved then. The centre was shut for many months at a time, so we lost a year on the project, but we're trying to make up that time now by bringing in more pieces of wing structure and fuselage structure to enable us to get more work done on NX611 during a 12-month period. So as you go forward, we will see more wing sections being restored, more fuselage sections being restored, and then NX611 for the next few years will be NX611 plus NX664 plus KB976. But what we plan to do is each piece of the Lancaster that isn't NX611 will be marked up as such. So once you see NX611 with nothing but NX611 on it, you know she is completely NX611 again, with all of her original parts back on and back as she should be, and all of the borrowed parts will be back at their parent organisations, back where they should be. And as a whole, NX611 will be airworthy. NX664 will be in a position where it can just be put back together again and displayed, and South Yorkshire Air Museum will have a nice displayable rear fuselage once it's been removed from NX611. So the whole project is funded by people like yourselves coming to the centre, the cups of tea and coffee that you buy, your admissions, a taxi ride on board the aircraft, a membership, and we also have something called the Rivet Club. The Rivet Club is a monthly donation to the restoration from £3 upwards, and for that monthly donation you get a weekly newsletter during the winter telling you all about the restoration work that's been done that week, and a monthly newsletter during the summer periods telling you about the work that's happening during the summer. That Rivet Club is currently raising the project between £80,000 and £90,000 a year. So it's very important to us that we keep that Rivet Club going, and anybody who wants to learn more about the process each week, I do the newsletters, so I'm biased, but I would recommend the Rivet Club is a very good thing for you to join, and it is making a very obvious impact. It is a big benefit to the centre with the work that we're doing. So we are completely self-funded in that sense. This isn't a fundraising drive, but we don't get any funding from any other government organisation. We pay full rates, full VAT, full tax, everything. So every little bit that we can raise does have a big impact on the restoration project. So I'm very grateful to you for your £10 or £11 admission fee that you've paid to come today, and your interest in the project. So thank you very much for joining me. If you've got any questions, I'm more than happy to answer them, whether you want to ask them now or whether you want to ask them more on a personal level. It's completely up to you. But mainly thank you very much for supporting us, and hopefully you've gained a little bit from this talk, and I haven't got to wake anybody up as I leave. Thank you.